Welcome, students, to today's Explainer. I am absolutely thrilled to guide you through a truly foundational concept in our software engineering course. Today, we're unpacking section 10.2 of our textbook, diving deep into sociotechnical systems. And listen, this isn't just some abstract theory. Understanding this exact concept is literally what separates a mere coder from a true software engineer. By the end of our session, you're going to see exactly why writing the code is only one tiny piece of the puzzle when you're building systems that actually have to survive in the real world. So, here is our syllabus for today. We'll start with an introduction to sociotechnical systems. Then, we'll break down the Sociotechnical Systems Stack. Next, we'll look at layer interactions and effects. And finally, we'll wrap up with a lecture summary and some vital exam prep. All right, let's jump right into Section 1, Introduction to Sociotechnical Systems.
You know, when we talk about computer systems, it is so easy to get tunnel vision and just focus on the code. But we have to remember a fundamental truth. Software and hardware are completely interdependent. Think about it for a second. Software, on its own, is just an abstraction. It's essentially just a representation of human knowledge, logic, and ideas. You can't touch it. Without a physical machine to run it, it does absolutely nothing. On the flip side, hardware without any software is just a collection of inert electronic devices. It's literally just metal, silicon, and plastic sitting on a desk doing nothing. Neither one is truly useful in isolation. But when you bring them together, boom, you create a powerful machine capable of incredible computations.
But here is the kicker. Even that combination of hardware and software isn't enough in the real world. And that brings us to our core definition for today. A sociotechnical system is a much broader system that includes non-technical elements. We're talking about people, business processes, and regulations, combined with technical components like computers, software, and equipment. The massive takeaway here is that a system's dependability is influenced by all of these elements working together. If you only focus on the hardware and the software, you're completely ignoring the human behavior of the people using it and the organizations governing it. And trust me, that is a guaranteed recipe for system failure.
Let's move on to Section 2, the Sociotechnical Systems Stack.
Because sociotechnical systems include human behavior, corporate rules, and government laws, they're way too complex to just view as one massive tangled web. So we break it down. We use the Sociotechnical Systems Stack to manage that complexity. It divides the system into 7 distinct layers, going from the physical equipment at the very bottom all the way up to society at the top. Now, I want you to memorize this hierarchy from bottom to top. It is absolutely vital for your exams and, honestly, for your future careers. Let's walk through each of these layers step by step so you understand exactly what lives where. We're starting at the very foundation, the equipment layer. This is exactly what it sounds like. It's composed of the physical hardware devices. Now, obviously, some of these devices are the computers and servers running your actual code, but it also includes things like routers, cables, sensors, and really any other physical electronic equipment required for the system to exist in the real world. Moving up one step, we hit the operating system layer. This is the software that directly interacts with that bare metal hardware we just talked about. Whether it's Windows, Linux, or some highly specialized embedded OS, its primary job is to provide a set of common facilities and resources, things like memory management and file systems. It does this so that the higher software layers don't have to stress about the specific nitty-gritty details of the hardware equipment below. Next up is the communications and data management layer. In the industry, you're going to hear this constantly referred to as middleware. So why middleware? Well, because it sits right in the middle. It bridges the gap between the operating system below it and the specific application you're building above it. This layer extends the facilities of the OS, providing the necessary interfaces and protocols that allow your system to communicate over networks, access remote systems, and manage heavy interactions with large databases. Directly above the middleware, we finally arrive at the application layer. This is where the actual application programs live. When you sit down and write code to create a brand new digital learning environment or a hospital patient management system, this is the layer you are building. It sits on top of the middleware and the OS to deliver the specific, targeted functionality that the end users actually need to do their jobs. Okay, before we climb any higher, let's consolidate this. These bottom 4 layers, equipment, operating system, middleware, and application, they make up the primarily technical portion of our stack. As a software engineer, this is where you're going to spend the vast majority of your time writing code and configuring systems. But remember our definition from earlier? A system is useless without people. So let's explore the top 3 layers, which are entirely human-centric.
Sitting directly on top of your application is the business process layer. This layer represents the specific day-to-day organizational business processes and standard operating procedures that actually make use of the software system you just built. For example, if you build a database program, the business process layer dictates the exact step-by-step actions a human clerk must take to input a new client's details into that system. It defines how the organization practically uses your tool.
Moving up again, we find the organizational layer. While the business process layer is all about those daily tasks, the organizational layer is about the big picture. This encompasses the higher-level strategic processes, the overarching business rules, and the corporate policies and cultural norms that dictate how the business operates as a whole. It basically governs why those business processes exist in the first place and sets the internal rules that absolutely everyone must follow.
Finally, at the very peak of our stack, we have the social layer. Listen, no organization exists in a vacuum, right? They all exist within a society. The social layer refers to the external laws, the national regulations, and the societal expectations that strictly govern the overall operation of the system. These are the absolute non-negotiable boundaries set by governments, because here's a hard truth. Governments do not allow companies to simply sacrifice safety for profit. Regulators, like aviation authorities or nuclear regulatory commissions, operate squarely at this layer. To comply with these regulators, companies building critical systems have to produce a massive, highly detailed document called a safety case to conclusively prove they're operating within the law. And get this, building that safety case can sometimes cost just as much as building the entire system itself. It is a massive undertaking.
So, to quickly recap the top half of our stack, we have the business process layer dealing with daily software usage, the organizational layer dealing with overarching company strategy and policy, and the social layer dealing with national laws and societal rules. Combine those with the bottom 4 technical layers, and you now have the complete 7-layer Sociotechnical Systems Stack. Now, I need to pause here and address a very common misconception students have when they first learn this. You might be looking at the stack right now and wondering, wait, where's the definitive software layer? The textbook makes a massive point of highlighting this. There is no single, separate software layer in the stack. Software is literally everywhere across it. The equipment layer is controlled by embedded software. The OS and applications are software. And even the organizational and social layers heavily rely on global software networks, like the internet, just to function. Software is essentially the glue holding the entire socio-technical system together.
All right, let's transition into Section 3, Layer Interactions and Effects.
In a perfect, ideal world, interactions in this stack should really only happen between immediate neighbors. The application layer should only ever talk to the business process layer above it and the middleware below it. Every single layer should neatly hide its complex details from the layers above it. But, as we all know, the real world is incredibly messy. In practice, you constantly see unexpected interactions between layers. A change in one layer doesn't just quietly affect its neighbor, it can create a massive ripple effect that crashes through the entire stack, causing absolute chaos for the system as a whole. And because software is so malleable and flexible, software engineers are very often unfairly forced to write incredibly complex code just to fix problems that were actually caused by bad physical design way down at the bottom equipment layer. A classic textbook example of this is the catastrophic Denver airport baggage system failure. Physical hardware flaws on the tracks forced engineers into impossible cascading software rewrites that ended up delaying the entire airport's opening by over a year.
Let's look at another fantastic step-by-step example straight from the textbook to see how this ripple effect builds from the top down. Imagine Phase 1. Society decides it cares a lot more about digital privacy, so the government passes a strict new privacy law. This is a massive change at the very top, the social layer. This immediately triggers Phase 2. The company must quickly adopt new organizational procedures to legally comply with that law. Naturally, this leads to Phase 3. The day-to-day business processes have to change, requiring all client data to be handled much more securely by the staff. So what happens to the software? Well, Phase 4. The current application system might not actually be able to provide the heavy encryption required by the new law. So extensive changes have to be forced all the way down into the communications and data management layer, the middleware, to completely upgrade the database security. Think about that. A legal law passed at Layer 7 forced a complex software rewrite all the way down at Layer 3. That is the ripple effect in action, and it proves exactly why you must understand the whole socio-technical environment, not just your code.
And that brings us to Section 4, Lecture Summary and Exam Prep.
Okay, grab your pens, because here is your absolute checklist for exam success based on Section 10.2. First, you must remember our fundamental truth. Hardware is inert, software is abstract, they must be combined with human elements to form a true socio-technical system. Second, you must be able to list and define all 7 layers of the stack, in order, from bottom to top, from equipment all the way up to society. Third, ensure you can accurately define middleware as the communications and data management layer sitting snugly between the OS and the application. Fourth, make sure you can explain the ripple effect using that privacy law example we just walked through. And finally, you absolutely must be able to explain the purpose of a safety case, why regulators demand it, and the fact that it can cost as much as the system itself. Memorize these, and you will have a massive advantage as we move into our next topics on building secure and dependable systems.
I want to leave you with a final provocative thought to ponder today. We literally just saw how a brand new privacy law can completely upend and break your software architecture. So if a change in societal laws can unexpectedly break your middleware, where does your responsibility as a software engineer actually end? You cannot just write code in a dark room in isolation. You have to understand the people, the business, and the laws that surround your program. Really think about that as you review your notes tonight. Thank you so much for joining this explainer. Study hard, and I will see you in the next session.